So today we are going to start off with module 4, which is Java, and basically the topics that we have to cover is programming with Java, overview of Java language, classes, objects and methods, method overloading and inheritance, overriding methods, final variables and methods, interfaces, packages, multi-threaded programming, managing errors and exception. So like I said before, in the previous modules we learned about object-oriented programming in C++, and then we are moving into Java, and Java is the basics for Android programming, so which is why we are following this order. And most of the things that you have learned in C++ can be applied to Java also as concepts. So if we look over here on the second line, we have things called classes, objects and methods. So basically classes and objects you're familiar with, and methods basically refer to functions that we had mentioned or discussed in C++. And the concept of method overloading can be analogous to function overloading that we had seen in C++. So likewise, we can study similar things in Java, but concept-wise and application-wise, it would be different from C++, which is what we have to learn in this particular topic. You can take a note of this site, which is known as www.jdoodle.com/online-java-compiler. This can be used for your compiling a Java program if you want to try it out. Some issue with the previous compiler that we did was we had to change the method name and all, so which would have been difficult, that I would be explaining one program in PPT and then you have to modify it in online GDB compiler. That would be difficult. So you could use this compiler to run your programs in Java. Java is basically used to develop two kinds of application. One is standalone applications or web, and then we have web applets. So standalone applications would be like your individual applications that are installed in your systems, like a calculator or a software that is based on Java. All those are standalone applications. And web applets Web applets would be requiring internet for its running and functioning. So we will be looking into web applets as part of one of our activity, and the remaining we'll run our programs and see. So now execution of a standalone application on a system would involve two steps. One is compiling the source code into a bytecode using Java-C compiler, and executing the bytecode using Java interpreter. So understand that there are two things over here. One is a compiler and other is a interpreter. So you have a source code which will be converted to bytecode using a Java-C compiler, and then it will be executed by a Java interpreter. Such introductory concepts are there which you can go through, but my focus right now would be on the concept of write once and run anywhere, or else WORA. WORA means write once, run anywhere. Now, the program that we are compiling in Java, it can be run in systems. So we can look into this in terms of hardware um, differences, like a 64-bit processor, a 32-bit processor, or we could take it in a concept of different operating systems, like you have Windows, you have Linux, and you have a Mac OS over here. So all these are three different uh, operating systems. Now, what is basically implied by write once, run anywhere is that you can write a Java program in a certain way, and it would be up to the individual systems to run it on their own. That is the concept of write once, run anywhere. Anyways, what it means is that the same program that is written over here, it can be run in different ways in Windows, Linux, and Mac OS. So that's a concept. So what happens is that your traditional languages like C, C++ were programs and compiled, and they used to be converted into a code that can be understood by the hardware. So if we try the running the same code in different machines, it would require various different compilation. So and it would be different for each hardware, so that would cause a kind of trouble in handling such programs. So the way C plus program is run in Windows would be different for how a C plus plus program will be run in a Mac OS. So that difference exists. Now that problem is somehow solved using a Java program by means of using a compiler and an interpreter. Now, the concept of interpreter and compiler we had looked previously. So, let us assume that a Java program is written. Now, when a Java program is written, when you compile it using a Java C compiler, it will create a bytecode. Now, the interpreter lies in each of these operating systems. So, the same bytecode can be given to each of the operating systems. Now, it would be up to each of this operating system to interpret the bytecode and to execute it in that hardware spec. Hope the concept is clear. You have a Java program. Now this Java program will be compiled over here and it will result in a bytecode. This bytecode is universal in nature. That means it can be used by a Windows system, it can be used by a Linux, or it can be used by a Mac OS. Now when due to its universality property, it can be read by any of these systems. It can be interpreted. Now each of this system has its own Java interpreter, and that interpreter will convert this bytecode into the required execution form. So that requires interpreter as well as compiler, and that helps a Java program to be Vora, which means it can be written once and it can be run anywhere. You don't need to create different versions of a Java program for Windows, Mac OS, or Linux operating system. The compiler and interpreter will handle the situation and solve it. These are some of the properties of Java programming. One, it is object oriented. That means, like just like C++, it can be run on object model. It is platform independent, like I said before, since there is a JVM virtual machine coming in, or the interpreter as such is called virtual JVM. JVM stands for Java Virtual Machine, and it helps the Java program to be run on any platform. It is simple, and if you understand the basic concept of Java, it would be easy to handle. Then you have the secure feature, which would be virus free and making it uh, you know authentication compliant. Then you have architecture neutral, like I said before, because of the Vora property. It does not depend on the architecture. It can be converted into a code which is executable on all kind of processors, and it is portable, like it does not depend on any other system specs or anything. So just like that, Java is again robust in its nature, making it an error eliminating one, because it can be able to perform compile time checking as well as runtime checking. I hope those kind of two error checking methods you're clear with. One happens at the compile time and other happens at the runtime. Multi-threading is another one feature of Java. You will be learning about it towards the end. But it would basically refer to the fact that a program as it is can be given different tasks to perform, and this task can run in multiple tasks can run at the same time. So this task here will be called a thread, and hence it supports multi-threaded programming. We'll look into it towards the end. We have a specific note for that also. Now, interpreted and dynamic would basically refer to the fact that it is capable of running in multiple systems. Just like the concept of object class and functions in C++, we have objects in Java also. We have a class also in Java. But the function thing here will be referred to as methods. So henceforward in Java, functions would typically be called methods. And then instance variable would be the ones that define the status of objects. So like if we have x and y variables, we already know that obj.x and obj.y will define the status of that object. So just like that, you have instance variables also. We'll take a look at a Java program right now. So basically, if you remember the concepts of oops, things should be easy for you. But let me tell you that Java has its own sets of um, functions and ways of running a program. So if you look over here, the definition, now the first point that I want to mention seriously here is that your Java program is case sensitive. Now, every time you are writing a program in Java, there are some certain things that you have to take care of. For example, if you look over here, this class, you have a class over here inside which you have a main function. Now, that main function is supposed to display the text called hello world. Now, if you look at this program, this is the class name. If you look at the class name over here, this class name begins with a caps. It is important. The class name should always begin with a capital letter. Now, if you look over here, you have some definitions for the main function over here. So this class basically accommodates the main function. Now, this main is defined as public, static, and void. Now, you have some arguments being passed over here, which is in the given by the name args, and which could be an array of parameters, which is of data type string. Now, just like cout we used in C++, here it's a bit different. You have a function called system.out.println, and inside the quotes will be given hello world. So that is how you write this Java program. So let's copy this particular program and see uh, what would happen. Like I mentioned before, there is this difference between different online compilers, which is reflected in the running of this program. So, I had previously mentioned that you would be requiring Java to be case sensitive. So, I'm using this JDoodle compiler over here, and if you see over here, I have a class called sample, which is given in small letters. And still, if I try to execute this program, it runs and you can see that there is this hello world being displayed. Now this is fine, I think, with this compiler, but when we look into this previous GDB compiler that we were using for C++, if you look over here, now this program, if I write it as sample, now if you look over here, this sample is in small letters, which means the class name is given as small letters, and I'm trying to run this particular program. You can see that it gives you an error like class sample is public. It should be declared in a file name called sample.java. There is some issue with this file creation over here. So what is required here is that this class name should be given in terms of main. Now when I give it under the capital name, capital MAIN, and try to run this program, you can see that it runs and it gives you the output that is hello world is displayed over here. Now again, if I look over here, I convert this to small main. See, now this is small m, and if I try running this program again, can see that it results in an error. So different online compilers are going to give you different responses, but generally it is said that Java is a case sensitive language, especially when it comes to usage of variables and all those kind of things. And in certain compilers, including all the syntax is also case sensitive, as I have shown over here. So I repeat the point once again. Java is a case sensitive language, and the behavior it differs from compiler to compiler, or the software to software. The behavior is different, and I hope these concepts are clear to you as an introductory topic to Java. We'll be looking more into the program side in the next video. So I hope the concepts are clear so far.